see. So, bali, ano naman ni siya, bali i-trim and i-polish ang video edit para hapsay siya in final edit.
Okay. So first, I'll be sharing the sample structural plan that we're going to use in this workshop. No? So this is just a small project, two residential house. So we're gonna try to model that in using SAP 2000, okay, and AutoCAD. So perhaps you're already aware that we can model a structure in SAP 2000 itself, but for much more complex structure, it's better for us to model it using AutoCAD and then import it to SAP 2000. Okay. So let me open our AutoCAD first. Ako naka-open na. Okay. Kenji, Kim Layam, Kate Ching, Kyle, Frisia, Kirby, William, Leynara. Unsa gito nga mga thesis topics gani ang naha inyo ha? I remember the bridge. Sa nga bridge yan eh.
Balo lang makasandig, sir.
Inyo ha to lay.
Yes, sir.
Okay. Sa tong uban.
Na seismic fragility for Cathedral and J.R. Borja Hospital, sir. Two groups.
Okay. Hospital and the cathedral. Okay, so mga landmark or high ang risk category is high. Okay. Do you have the structural plan? Kindly download it first and familiarize na lang, no? Para later when modeling the structure, mas smooth na nga to ang progress. Okay. Sorry kaya nakalimot kung turn on sa AutoCAD.
Naka-mute ata.
So we're going to create a new project using AutoCAD. Talaga AutoCAD. Okay. Okay. So the first thing we do is we set our units. Mm-hmm. Okay. So our drawing units must be in meters. That AutoCAD and our SAP 2000 must have an agreement on what units to be used. So we need to define our units in AutoCAD first. Precision and decimal place regardless na kung saan ano. Basta kay our insertion scale is in meters. Click OK. Then uh, we refer to our structural plan. No? Refer to structural plan. And we can see in our structural plan that we have around 3, 6, 9, 12, 14 columns. Okay, so we have 14 columns. So we're going to create a stick model for that structure. So we switch to 3D view. Switch to 3D view, then let's create the first line. But before that, we check the elevation of our structure. So from ground to second floor line is 2.6 meters, and we discount the depth of the beam. The depth of the beam is 2.3. So we create a line with a height of 2.3 meters. Okay. So first line, then yung spacing is 3.35, then duwa ka 2.9. Okay. All right. Okay. And then in our layer, we create layers. No, we assign layers to each element. Let's create na lang everything. We have a layer for the column and the beam. Siguro start na dali, no? Create layer for column and beam, and we assign these lines. So we assign this one to column, and then we try create the beams. Try to create the beams. So for the beams, we refer to the structural plans kung asa naka ang location for our beams. Okay. And then we continue by creating the second floor columns. So for the second floor column, the elevation is 2.5. And then we discount the roof beam 200. So we get 2.3. Okay. Then we create the roof beam again. All right. Forgot to save our forgot to save our model. So let me save this one. Classes first. All right. Then for easier na coordinate system nato sa tuang drawing, let's move this whole thing to origin 000. No. Okay. Then let's move this whole structure to the center. No, to our 0. All right. So balay na niya ang structure geometry sa tuang residential house. And then now we're going to save it as this file as AutoCAD 2010 DXF file. Okay. All right. And then we exit so that it can be, it's important that we exit our exit file. So our SAP can edit on it. No? Then on SAP, we open SAP, click on the file tab, select the menu for the import, and then find DXF file, AutoCAD DXF file. Then a window will appear. Ato pangitaon kung asa nato na save ang file. So I have here the sample. Okay. So global up direction is Z. Units, kilonewton, meter, and Celsius. So you have several units that you can use. But for this model, we're going to use kilonewton, meters, and degree Celsius. Then click OK. Then another window will appear. No? So depending on what you want to import to SAP 2000, then you'll have to select kung sa imo ang gusto. And for us, we want to import the frames for the line elements. So click on the frames, then column, then click OK. And if we click on the 3D perspective, the columns are now can be seen in our SAP 2000. Okay, and if you select okay, later na lang. Then we do the same process. We add the beams. We add the beams. Same options. Frames, beams. Okay. There. No? So now we have the beams. Then our structure from AutoCAD is now on SAP 2000. Of course, you can create a structure, or you can model a structure in SAP 2000. But for complex na mga structure, it's better to model it on AutoCAD first, now before going to SAP. And what you will notice here is that if you go to the Define tab, and click on the groups, no, the following are created automatically. So this represents, although it does not have the same layer name on your AutoCAD, but this represents the layers sa imuhang, or the layers that you import from AutoCAD to SAP. So for example, the first layer that you imported is a columns, and DXFIN is represents the columns. So we can rename that columns. Click OK. And the second one is the beams. Click OK. We can check if we are right about our groupings by using the selection tools, no? So those groups nga to ang rename ganina will appear on our groups, on our selection tool. So to open the selection window, click on Select tab, then select by group, no? And if you try to select beams, okay, so automatically it will select all the beams, all elements under the group name beams on your model. And if we click on columns, it will automatically select all columns in your model. All right, so those are the basics. For the basic functions, or for the basic tools in your SAP 2000, it's just the same with your AutoCAD. If you want to create a line, then find the drawing palette in your left side, and you'll have the following tools, no, such as reshape element mode, draw a special joint, draw frame or cable. What else? Draw a poly area, or if you want to model a slab already, so you can use that. Okay. Then if you want to pan through your model window, then you can use the center button on your mouse, no? If you're using a 3-wheel mouse. But if you're not using a 3-wheel mouse, then you can click on this pan tool, no? Is symbolized by pan, no, to move around. And if you want to rotate sa imuhang model, if you want to have a different view, then you can do this one, right? Okay. You can also have different views on your screen. You can have XY meaning top view, no? You check na lang your you check your ordinates, your axis, XZ, ZY, etc. No? Okay, so this is your 3D button. You can zoom in, zoom out by using the roller on your mouse, or by clicking the zoom out one step or zoom in one step on this, So everything is more similar lang siya to your AutoCAD. Okay. So, okay. Germs, can you in the chat box, can you type in the course overview for this workshop, so wala pa ma-miss? Ako tong gitype sa una yan. Kalimot na ko asang itong file. Please terms para delay ka mawala. Okay. So moving forward, we have now a model. If you have questions, if you have questions, if you have concern, just raise your hand, no? So para ma-address na ko diretso. Depending on your preference, depending on the preference of the structural designer or the structural engineer, you have the option to whether model the tie beam or not, no? Model the tie beam or not, no? So for me, I do not model the tie beam in my model because I'm assuming that my tie beam are only used for to tie the columns around, no, to prevent settlement and dili siya murag element that resist force from loads coming from the building or from the other structural elements, but rather it is something that is there para if ever magsettle ang imuhang building, then it will settle uniformly. No? Just imagine if nakatay ang imuhang tanan columns, then if ever na isa ka column nga mo sink, then for the building, para for that column to sink, no, kinahanglan dalon pa niya ang tibuok ni mga building. Mura ginana lang ako ang think about tie beams. But of course, you have the option to model the tie beam also. That way, you can derive the forces, and you can design it respectively. Okay. Yeah. No. And next that we do, okay. No. Thank you very much, Germs. That is creating your project. We're already done with that. Setting views. Okay. Setting views is that one. No, kini nga mga button na rin. That is your views. You also have the option. You also have the option to have another view on your SAP. No, by clicking this drop down menu here, then click add new window. So on one side, you can have siguro XY. You can have the top view. And on the other side, you can have the 3D view of your structure. You can also change on your XY plane or in this right side on your screen. You can change the elevation of your XY. No, you can change the elevation of your XY plane by clicking this one. This is elevation z equals 0, 4.6. Okay, duha ra iyahang gipakita, no? So edit your data. No. All right. Anyway, so setting units. So when we were importing the AutoCAD file to SAP, we already set units. but just in case you want to confirm or you want to check your units, you can find it on the lower right portion of your SAP, no? Dali mo pwede ma-change ang imuhang units. Okay. Okay. So you can also change the elevation. You can also change the elevation kung asa imuhang gusto tan-awon, no? So by clicking this one, we are set on the XY plane. What if we want to look at this one, no? The 2.3. No? Kita ninyo? Pwede nato i-change ang level. And we have these grids as guide. So this one is the ground level. This one is the second floor level. Is the top one. The topmost is the roof level. Okay. So you just go to view, set 2D or set 3D view, and etc. All right. So that's it. Me really, I don't really use two kinds of view. So naanod lang ko nga duha. Pero siguro for if you are modeling na complex structure, then you may use the that 2D view para mas paspas mo maka-create og slab. No? So kana. Next. Defining materials, defining sections. Okay. So we go now to defining materials. So bali ang imuhang SAP 2000 tabs is arranged accordingly depende kung unsa imong kinahanglan. Of course, first kinahanglan nimo mag-open ng mga file and edit things. If you want to copy, paste, add, replicate, extrude, etc., then you'll have that one. And if you want to set your views, then you also have the third tabs. Then next step is the define material. So first we click on the define tab, and then we define materials to be used. We go back again to our structural plan. We check on the materials used or on the specifications of our plans. No, say here we're going to use 21 for footing. We're going to use 21 megapascal or 3,000 psi concrete, and for steel we're going to use grade 40 steel. Checking on our columns, we're going to use the same materials, 3,000 psi concrete in grade 40 steel. What else? We go to our beam, same materials, and etc. No? So I believe kato ato ang mga things na kinahanglan i-define sa ato ang materials. So first, we add material property United States because our codes are based on the United States. No, we have ACI or American Concrete something, and for steel we have American AISC, American Institute of Steel Construction, AISC. So all American. So in ASTM standards also. So for steel we have ASTM 992. Then just check on okay. All right. So based on ASTM, we only have A36 steel, no, or 36 KSI steel, or we can create a new, we can create a material, no, by providing the weight per unit volume, the modulus of elasticity, the Poisson's ratio, coefficient of thermal expansion, the yield strength, FU, FY, and FUE. So we can provide that one. So for this workshop lang, we're going to use lang sa what is available. So let's use grade 36. And And for concrete, add new material, United States, concrete, customary, and 3,000 PSI. All right, so kana siya. No? Click OK. We're going to define our frame sections. How to define our frame sections. Add new property. By default, no. By default, we have a W18 by 35 depending on the version that you have a SAP. Para lang na siya masulod diretso. So select na to concrete, rectangular, and let's label this one as column. And then the depth is, check na to sa to ang plans. We have there C1 250 by 250. So let's use that one. So our units is in meters, ha? So that is 0.25. Materials change as 3,000. Section properties. Okay. Concrete reinforcements. Longitudinal bars. We click on copy material, select A36. Oop. Column. All right. Okay. Clear cover for confinement bars is 0.04. Number of longitudinal bars along 3 direction and 2 direction. So 3 direction is the weak axis and 2 direction is the, 3 direction is the strong axis and 2 direction is the weak axis. Okay, so going back to our plan, nalantay duha and duha. And we have 16 diameter. Confinement bars or our ties, we use 10 diameter. Longitudinal spacing, we have to check on our plan. It says here 100, rest at 200. So siguro on for your sa inyong respective na mga structure nga i-model, you count manually how many ties are there, then divide that to the length, no? Then you get the spacing of your confinement bars. All right. Okay. Number of confinement bars in 3 direction. That is 2. This one is also 2. Then the enforcement to be checked. Okay. I'll go back later to the material, rebar material, ha. I'm having a bit an error here. Hindi na ako maklik ang other materials. Anyway, so that's it for now. Set modifiers. Okay. You can also set the modifiers for your column depending on the code that nga gusto niyo nga imuhang i-refer. No? For now, let's just leave this one as is. And independent properties. Okay. Section properties, or column. Okay. Click OK. Then we model our beam for this plan. We have 200 by 300. So let's call that one as our beam. Depth is 0.3, width is 0.2, 3,000. And then concrete reinforcements, beam, no? Okay, dili gyapon siya gusto. 836. Okay, anyway. So concrete cover to longitudinal rebar center, that is to the rebar center. So that is 0.04 plus 0.008, 0.48, 0.48. Reinforcement overrides for ductile beams, 316. So you get 316, 316, 3, 3. Okay. So, kana sa ito ang mga paggamiton. Anyway. Alright. Okay. Okay. And we're going to assign those elements. First siguro, we are done with defining our materials. Select groups, select beams, and then click on assign. Click assign frame and frame sections, and then beam. Apply. Okay. And then select columns, and then apply columns. Okay. And if you zoom in, your column are now labeled as column, and your beam are now labeled as beams. Ano? Okay. And I can also extrude the structure by clicking on set display options, general options, and extrude. And ano ang itsura niya. Okay? So makita na ako ang geometry mismo sa ko ang structure. So na ay ano. Okay. Okay. So that's it for the general options, standard. Okay. Siguro next we create slabs, no? We create slabs. So on my plans, using draw rectangular area or draw a poly area, click on the joints kung asa na ay slab and select enter. Okay. Mao sila ako ang second floor, no? And define again, balik ko sa define section properties, area section, modify. Okay. So let's rename this one. Sabi, marag wala pa nakita. Define area sections, no? Area sections, then click on modify, then slab. Thin shell membrane is 0.1, no? 0.1 ang thickness ato ang slab. Okay. Excuse. Okay. So thickness slab is 100. So 0.1. The bending of our slab is also 0.1. Then we select 3000 psi. Okay. Shell thin. All right. All right. Okay. So this is let's focus on the analysis lang sa nga part here ha para mahuman nato ang workshop. Ito na tayo next time na punta sa design. So kato siya. And then using the select tool, no, or akong cursor lang, I click on the slabs and then I define section properties, area sections, and then slab. Click OK. Okay. And so if I right click on the slab, it will show this assignments, no? So I have the section name slab. So naka-assign na kibali to akong giset na modifier sa iya. Click OK. So we are done with the columns. We are done with columns, the beams, and the slab. Now we define the load combinations, the load patterns. Load patterns. First, we have the dead load. I'm sure you know what the dead load means. It's very important that we model the cross section or the section, the geometric properties of our elements para we can input 1 on our self-weight multiplier. What this means is SAP will automatically compute for the self-weight of the elements that imuhang gi-add sa program. For example, slab thickness is 0.1 and automatic na niya i-take into account ang self-weight itong slab nga imuhang gi-model. Column 250 by 250 millimeters, iyahan nang i-automatic pag-compute ang iyahang self-weight. So that is for dead load. And then we type in live load. Then the type of load is live. So you'll notice na for live load, dapat 0 na ang imuhang self-weight multiplier. Then add new load pattern. And then we also have, what else, no? Dead load, live load. Siguro if you have roof live load, roof live, then enter po nimo dara. Roof live. Or if you have earthquake load, earthquake, or I think it's seismic load. So, oh, it's earthquake die. So add, and if you have wind load, wind, add. No. So for seismic and wind load, you have the option to automatically calculate the loadings. But for you, no, I will not recommend doing this one. I recommend that you manually calculate the seismic and the wind load and you apply it to your structure. Then we click OK. Click OK. Then we define again. We go to load cases. Load cases. All right. Sorry. It's something like load combinations. So say for example, you have a load combination of NSCP section 203, sorry, ito mo section 203-0. Ano lang, kalimot ko sa iyahang code name. Let's just call this one 1.2 dead load plus 1.6 live load plus 0.5 roof live. No? So dead load, scale factor, we input a scale factor here, 1.2 for dead load. And for on the drop-down menu, you'll notice nga katong mga loads nga atong gi-add sa SAP is mutunga po ani na menu. So live load 1.6 add, and roof live load is 0.5. Okay, so sample lang ha. Kana. So we already have our load patterns defined. And now let's assign loadings. Now let's assign loadings. So to assign frame loads, no, you'll have this window. Asan mo gusto i-assign ang ano. Say for example, gusto nato magbutang og these are imposed loads, no? Gusto nato mabutang o concrete masonry units along the perimeter on the second floor, no? Sa second floor nga portion. So, global, balik ta, assign, frame loads, distributed. Okay, so we'll have this button, and then gravity, okay. Global, you can have either global or local na coordinate system. Global meaning it will follow the global coordinate system of your structure. Local meaning it will follow the coordinate system of an element. Say for example, naka-slanting, naka-element na rin nga slanting, no? Na lugar, na slanting ni mga element. So, ang iyaha pong coordinate system ani is ma-change, no? So bali ma-slanting po yung coordinate system. So mo to yung follow na local coordinate system dayon. So that's the difference between global and local. Assign frame loads, palikta. Let's just say na you need to distribute a force of 7 kilonewton per meter along the perimeter of your second floor. So uniform load, click on negative. Sorry, this is gravity loads naman, no? So pwede nimo i-define ang load direction sa imong SAP by X, Y, Z, or gravity. Gravity meaning the positive direction is going downward, kay gravity man siya. If you click on the X direction, then your loading is pointing also to the positive X direction. If you use positive Y, and then your load will point out, by default, your load will point out to the positive Y direction. So here we are going to use gravity loads, meaning the positive direction is going downward. So there's no need for us to put in negative. Just then if the weight of our concrete masonry units is around 7 kilonewton per meter, and then we select, if you don't select anything, then you won't have the option to apply the load. So select the members na gusto ni ma-applyan og load, no? And click apply. Para so, makita ni mo tong load na ay 7 na nakabutang. Ang gamay lang ako 7. Alright. Click OK. And for the slab, siguro for the slab, assign area loads, then uniform to shell. Click uniform to shell. And for dead load, say you take into account for your dead load, no? I know you're familiar, you're all familiar with this, na? From your theory of structures. You take into account the interior partition, the tiles, the grout, the mechanical, electrical, and plumbing fixtures. So muna ibutang yapan mo na siya as dead load. And then here, on your fourth option, you have load distribution, either one-way or two-way. So two-way meaning ratio between short and long is less than 1, I believe. So ratio short to long. What's one way gani? Sorry, nalibog ko. 4 2/4.
Greater than 2, sir.
Okay. In terms of the ratio between the short and the longer length. 0.73. All right. So kung anyway, kung ratio between the longer and the shorter length, if greater than 2 ang imuhang ratio, then that is one way. Then if less than 2, then that is two-way. So depende, no? Siguro dari we can say that this one and this one is in two-way, and let's put a load there of 2.35 kilonewton per meter square. So this is just based on my experience lang kining 2.35 ha. Depende ni siya sa inyong structure. So you need to take into account on sa mga dead load na sulod sa inyong structure. Click apply. Okay. And this one will be one way 2.35. All right. So kana siya. If your take note, if your floor system is steel decking, it's always one way, regardless of the ratio. Regardless sa ratio sa imuhang length sa imuhang slab, shorter length versus longer length sa imuhang slab. Floor system using steel decking is always one way. No. Tungod sa geometric property sa imuhang steel deck. Let me show you. Paint. Okay. So your steel deck manggod. Okay, I'm sure nasa inyo uban na school building ang impang model. So naay mga school building nato nga steel deck. Mura ginani itsura sa imong steel deck. No. And sa plan view, mura na siya og kini ang imong kanay imong beam, kini imong longer length and kini imong shorter length. Ang itsura din sa imong steel deck is painani. So kaning imong mga groove na siya dara. No. So it's the way steel decking distributes the load is one way tungod ani sa iyang mga grooves. It's hard for steel deck to distribute the load to these two beams. No, it will always distribute the load to perpendicular aning iyang mga grooves. So dari ra perminti niya distribute ang loading. So that's why ang imuhang steel deck is always one way system. Okay. So all right. Okay na siya. Sa paman. Siguro you apply na lang tayo, no? Depende sa unsa pang load ninyo. You have to apply the roof live load. No, roof live load. What else? Wind load, earthquake load. You need to do that. Yeah, the live load. We need to define the live load also. So select on assign again. Area, uniform to shell. And then live load, two-way. Let's say this is a residential house, so 1.9 kPa. Then click apply. Then one way on the other side, apply. Okay. So now you have defined already dead load and live load. What's lacking in this model is the roof live load that you need to compute, then put in the joints sa imong building. Okay. And the earthquake load, no? Kinahanglan nimo i-derive, kinahanglan nimo i-solve ang imong earthquake load and apply it to this structure. Okay, then after defining the loads, it's also very important to assign joint, no? We need to assign restraints. Otherwise, mulupad ang imuhang building kung mag-analysis na ka. So just imagine that this restraint will provide unsay mo'y ga-provide sa as a support sa imong building. So click on the joints, no? Click on the joints sa imong column. Then select pin, no? So magdepende gyapon ni siya sa ga-analyze. You can have that one as fixed or you can have that one as pin, depende sa connection sa imong building. So kani atong building diretso siya from column to ground, no? Column to ground siya. So ang imuhang yuta will have the capacity or will have the resistance against FY, no? Lateral loads or FY, and against side movements, di ba? Pero wala siya capacity to hold or to resist moments. Di ba kita mo ang mga building nga kakatumbling siya. So mura ginana ang representation sa imuhang pin. So although naa siya resistance to sliding and resistance to gravity loads, pero walay capacity mong yuta to hold down your building against moment. So mo na ang ako ang thinking. So depende sa imo napoy uban nga mga designer nga gina-assume nila as fixed. So depende case to case basis. So kinahanglan ninyo i-check sa inyong plano. Say for example, ang imuhang building is naka-pile foundation. No, naka-pile foundation siya hantud sa pinaka ubos sa yuta. So pwede nimo siya i-assume as fixed, no? So depende sa imuhang thinking, or if ever lahom na kayo ang imuhang foundation, then pwede nimo siya i-assume as fixed. So depende, magvary niya siya sa personal preference, sa designer. Click OK. Now I believe we have everything. No, we have defined, we have created a new project, set the view, set the units, define materials, define section properties. We already know about defining groups, defining load patterns, defining load cases, defining load combination, assigning joint restraints, assigning sections, assigning loads, assigning to group. So nanata sa number 14. That is to run analysis. So click on run analysis. So to run analysis, you can click this play button here, or as akong giingon ganina, no, your tabs is arranged depende sa imuhang need, no? So kung nahuman na ka sa each tab, check nimo ning analyze, then okay, click run analysis, no, and you will have the following. Okay, so let's check on this one. Okay, so analysis, run analysis, and then run now. Oop, wala pa na ako na-save akong model na eh. Gani wala nag-crash. Okay. So, SAP will now analyze the model, no? So, karon makabalo ka na human na siya pag analyze, it will show you the yahang deformation. Ano, will show you the deformation of the building. So let's just stop animation. Then dali dayon, no? Sa show forces or sa imong display, no? Either either from these options or from display, di ba? Kung analyze sa display na ta. So dari ka show deform shape or show forces and stresses. Oops, ito. Yeah, ikaka-click siya. Okay. So we can click on joins, no? And click on our load combination. Then click apply. Then you will see the results, no? So naa kay 9.34 kilonewton dari, 9.96 kilonewton, etc. for your load. You have the option to whether show the values of the forces sa imuhang joint reactions, or you can have it tabulated, no? Tabulated or arrows. Okay, and close. We go to frames and cable, say this load combination, and then click on axial force, apply, no? So it will show axial forces. Click show values para ma-show ang mga value. Then you have that one, 76 kilonewton, 84 kilonewton, etc. And if you want to show moment 3-3, moment 3-3 is the strong axis and 2 is the weak axis. So moment 3-3, okay, you have that one. No, you have that one. And moment 2-2 or on the weak axis, no. Then what else? Shear 2-2. Okay, so shear 2-2 nga shear and moment 3-3 is pares. 3-3 is 2-2 is pares also. Of course, I know you already know that from your theory. No? So pares ang imuhang x, pares ang imuhang x nga shear, imuhang weight. Start sa weight, no? Imuhang weight along y-axis is mao ang mag-cause sa imuhang moment again on your strong axis, and your imuhang weight from y is mao imuhang strong axis, x, no? 3-3, and imuhang x is mao mag-cause og moment to your weak axis or 2-2. So mo pare sila duha. Okay. Apply. All right, so you'll have that one. You have the shear and moment diagram. Okay. Join. So that's it for showing the results. And then siguro what I missed dari, no? What I missed dari is kinahanglan apply. Kung ma-notice ninyo ang atuang slab, no? Atuang slab nga deform siya palayo to that beam, no? So I guess I missed kanang dapat ipapilit na ako sa tanan sa akong beam, no? So what we're going to do here is para ma-edit na to model, we need to click this unlock button, no? Unlock button, or on the analyze, we can pili na lang unlock button sa okay, unlock button, and then we edit areas, and then divide areas by okay, divide areas 2x2, apply. All right, siguro click na to tanan 2x2. Okay, scan analysis again. Okay, so better. No, you need to edit the slabs para mo sabay siya sa imuhang beam, sa imuhang SAP. So again, akong gibuhat ato is unlock model, okay. And then select the slab that I want to edit, that I want to subdivide, then click and edit areas, then divide areas. Then depende kung pila ka divisions ang imong gusto. The more divisions, the more accurate ang relation load transfer from your slab to your beams, or ang iyang deformation, ang relationship between sa deformation sa imong beam and slab. So importante nga imo siyang i-divide para pag run nimo sakto ang ilahang pag-deform. Okay? So kana siya. Question so far? Question?
Sir, naki-question.
Yep.
Sa column, sir, ba kay apilon pa ang footing pag sa height or ground above lang?
Okay, depende sa imuha, no? Depende gyud siya sa imuha. But to be safe, bali depende siya sa preference man gud sa view. So I believe your mentor is Sir Dex. So he prefers that you model the tie beam and the length sa imuhang and the length sa imuhang footing below ground, no? So kana pwede ninyo buhaton i-model ninyo ang tie beam and i-model ninyo ang footing. Balik kini ako nga buhaton na rin for commercial purposes na ni. Dili naman kayo sila specific sa mga clients ang i-model pa ni mga footing. Same lang man yapon anyway. Pero for academe, I believe you have to model the length of the column up until padulong sa imuhang foundation. Okay na. Any more questions? Question?
Hi, sir. Kanang mag-ask lang ako if naay other analysis nga madu sa SAP.
What exactly do you want to do, man? What kind of analysis?
Like push over.
Yeah, you can do pushover and SAP. You can do pushover on SAP. You can also do dynamic analysis on SAP.
Okay. Thank you.
Lagi germs, no? Siguro kanos ano niyo i-take in yung earthquake engineering? Kabalo na mo kanos ha? Or human na mo?
Murag next sem ata,
Wala.
sir. Or di ko sure.
Next
Pero
sem.
current wala pa.
Flip pa currently.
Anyway, I recommend reaching out to Jameson team na lang balik James, no, for the pushover analysis on a different session. Kay what's important here is ma-master ninyo ang basics sa SAP, no? Kinahanglan makabalong model sa mga buildings and extra na din pushover for the next session. Siguro schedule na lang ninyo, James. I believe masugot to si Jameson, butan man to.
Sir,
Sige,
Yeah.
sir.
question.
Yes, Kyle.
Kanang sa SAP, sir, ba kanang makabutang og like soil index or anything related sa soil, like coefficient char?
What for? Why do you want to put soil parameters?
Kay ano man, appeal siya sa sa bridge.
Yeah, what are you trying to do, man? The design of the investigation
Ay,
of
ano,
the
sir,
soil?
soil interaction, sir. Soil structure interaction.
Soil
SS.
and I'm not sure about that. I'm not sure about that. I heard you need to have another program for the soil interaction. Wait,
Okay. So lahi siya na ano, sir.
yeah,
Dili siya.
I think you need to use another program with the soil interaction.
Okay po.
Okay, for SAP, it is for analyzing elements man lang and calculating forces. So kung balik madto ka sa soil, lay ata to ilang gigamit. Can you ask na lang the ano? Can you ask your ates and kuyas? Kinsay reference ninyo gani?
Sila ano, Gupay mata.
Kupay?
Kupay.
Oh, butan man to si Garni.
Sige, sir.
Oh, paano lang mo saya or better, you read the whole book. I don't know if you have read already the whole book of your ates and kuyas nga inyong gina-refer inyong project. So siguro kato na sa inyo ang una buhaton before reaching out sa ilaha.
Yeah.
Yeah. Okay.
Sige, sir. Thank you kayo po.
Okay. What else? Ignalan ko germs ha kung ma-set ninyo si Jameson. Basin busy po to siya for their board exam.
Bali ano sir, bali siya ang i-contact na mo siya para siya mag ano sa katong push over sir or
Siguro. Oh yes, correct. Oh.
sige sir.
So I strongly recommend nga you fast track your study on your specific na mga field before reaching out dayon to mga resource person, no? Kay I know nga mas lisod man gid karon kay online. So kung makig-istorya mo sa inyong resource person nya dili pa kayo mo familiar sa inyo hapong area, then there will be a disconnect when lisod siya i-resolve tungod kay online lang ta. So kana fast track the way you study inyo mga specific areas, basahan na to ilang mga libro hud pagbasa gikan chapter 1 padulong chapter 3. Then para maka-move on na mo, no? Para next sem lain na po yung mga things finalization na lang diretso. So I believe vital ka ito nga na mo earthquake engineering. So karon taas ang semester, 5 months pa mahuman ang semester niya, wala pa mo earthquake engineering. Kato na lang sa gyud basahan ninyo ang libro, dayon reach out na din mo diretso sa inyo ang mga resource person para maka-ask na mo questions diretso. Okay? Okay. Questions? Ano pa? Wala na? So we end this presentation. All right. Kina Germs? Wala na may question ha? Anyway, kung namoy mga hunaw-naan kalit yung mga question regarding your study, send na lang message dito sa kuha. Okay? Para, although dili ta mo ma-answer, dili na ko ma-resolve dili sa inyo mga problem, pero basin mag-guide ta mo asa mo padulong. Alright.
Kuan si sakto to sir murag kuan siguro karon kay murag na diretsuan man mi sumurag pending pa siguro among question if mag-actual na migbuhat like kana mag-try na gid mi. So basin diya ra arise sa question. So
Correct.
update lang mi siguro ana.
Sige.
Tapos fun pa clarify ko sir if unsay after ani di ba kay na record na mo ni tapos i-play sa September 15 na ana sir no during the time
Let me know kung unsa ang program. So siguro while the video is playing, Dili siguro ko appeal dito, pero sa question and answer portion, I'll make myself available
Ah,
para makabalik po
yeah,
mo
kana
sa
siguro,
katong
sir.
mga nagkanta. Yep.
Yeah, I think murag ano mo siya, murag na redundant po siya sir ba for the sake na naana lang program. Pero pwede na siguro sa question and answer kay mo man dito important tapos basin maka come up with mga compiled questions po. So sige.
All right.
Wala na tayo line
So,
question guys.
again what we did here is ato lang gibuhat dari is the analysis lang gid nga part and sa pag-model sa mga loads and everything, pero wala pa kita nayabot dito sa part na mag-design na la. So, kato lang sa inyo i-master.
Analysis.
Okay.
Yeah. Wala na tayo question guys, no? 10 seconds. Yeah. I think sir, understandable nga wala gid me specific question as of now kay iyo pa man may mag-try after na mo matanaw ang recording, so mag-try siguro mi ug kanang kamisa tapos basin dadto na namo ma-raise ang question.
Ask questions. All right.
So ayan, so once again siguro sir, thank you for
Thank you very much.
wait lang.